All right, moving on to week 1, day 3 lesson videos. In this lesson, we are going to talk about solving systems again, but this time we are going to talk about the substitution method and the elimination method. So this first lesson video is going to be focusing on the substitution method. Now, ideally for the substitution method to work, you would want one of your two equations to have a variable isolated, either the x by itself on one side or the y by itself. So here for the example number 1, we do have such an equation where y is isolated on the left side of the second equation. You have y equals 8x plus 7. All right, so we're going to start with that equation. Y is isolated, and it's equal to the expression 8x plus 7. So we're going to take that expression that y is equal to, that 8x plus 7, and we are going to substitute that expression in for y in the other equation. So where y is in the first equation, we're going to sub in 8x plus 7. And this is what it's going to look like when we do the substitution. All right, so you notice that everything in the first equation is pretty much still there, except for where y was next to the 5. So we have 8x plus 5, and in parentheses where y was, we are now writing 8x plus 7. We are substituting 8x plus 7 in for y in the first equation. And we're going to finish off writing that first equation with equals negative 13. So now you notice after we're done with the substitution that we are looking at an equation with just one type of variable. In this case, the x's. All right, so once we've accomplished that, now we're going to go ahead and solve for x in this equation. All right, so when we solve for x, we get x is equal to negative 1. Now again, we can't forget, since we're solving a system of equations problem, the solution is going to be an ordered pair, meaning we need to find the y value. We found the x, we need to find the y. So I'm going to use the second equation, the y equals 8x plus 7 equation, to help me solve for y. Now that we have a value for x, I'm going to plug that negative 1 in for x in that equation. And that's going to allow me to solve for y, and I get y is equal to negative 1. So now that I have an x and a y value, I have my order pair complete. So my solution for this system is negative 1, comma, negative 1. Let's move on to example number 3. So again, we want to use the substitution method. So we're going to start off where we have one of the variables isolated. In this case, again, it's y. What does y equal? Y equals 2x plus 8. So we're going to take that expression that y equals, that 2x plus 8, and we are going to substitute in for y in the other equation. So that substitution is going to look like this. Negative 6x plus 2, and in parentheses, 2x plus 8, close parentheses, equals 16. So we've solved for, now we need to solve for x. And what we do, we get x is equal to 0. Now that we have a solution for x, we have to be looking for a solution for y. So again, I'm going to take that second equation and use it to help me solve for y. And what we do, we get y is equal to 8, thus completing my ordered pair. So my ordered pair solution for this system is 0, 8. Now we're going to take a look at example number 4. Again, doing the substitution method, we see, again, we are going to start with our y equals equation. Y equals negative 7x plus 6. And that expression, we are going to take it and sub it in for y in the other equation because that is a y equals expression. All right, so this is what the substitution looks like. Now we're going to go ahead and solve for x. Again, we need to simplify that left side, trying to solve for x. All right, so we're going to distribute the 3 through the parentheses, and then we're going to go ahead and combine like terms. But you notice here that when I combine 21x and a negative 21x, that combines to 0. Not 0x, not just x, it's 0, right? 21x minus 21x is 0. So the variable that we were trying to solve for also got eliminated in this step, right? And you notice that we are left with no more variables to solve for. The y's are gone, the x's are gone, and all we're left with is this statement. It says 18 equals negative 3. Now we know that 18 doesn't equal negative 3. So that's going to make us think about how this problem is going to end. Again, if there is a solution for a system, that means we found a value for x and for y. Right? But the y's got eliminated when we did the substitution. The x's got eliminated when we did the substitution, leaving us with no variables to solve for. So the statement that we're left with, again, is not true. In a situation like this, when you're solving a system algebraically, using either the method of substitution or elimination method, when the variables go away and you're left with a statement that is not true, then your answer is going to be that this system has no solution. Let's move on to example number 5. Again, we want to use the substitution method. All right, but this time around, we do not have an equation that has it starts off y equals or x equals. We do not have an equation that has a variable isolated. However, we take a closer look at the second equation, we can easily change that to x equals. All right, so I'm going to rewrite that second equation where I'm going to subtract 3y from both sides. So now I have x equals negative 3y plus 16. Again, if I'm going to do the substitution method, I need one of the two equations to be either y equals or x equals. Again, it doesn't always have to be y equals. See, with this example, we can do an x equals for our substitution. So we have an x equals negative 3y plus 16. We're going to take that expression, negative 3y plus 16, and in for x, this time in the first equation, we're going to sub that in. And this is what it's going to look like. Okay, so we're subbing in that negative 3y plus 16 in for x in the first equation, giving us this equation with nothing but y's. So we are left with trying to solve for y. So we've got to simplify that left side. All right, so when we solve for y, we get y is equal to 4. All right, so now we do have a solution for this system, and half of that solution is y equals 4. So we need to find the other half. We need to find out what x equals. So again, I'm going to go back to the original problem, and actually I'm going to go to the modified second equation where I have x equals negative 3y plus 16. Now I'm going to use that to help me solve for x. All right, so I get x is equal to 4. So that completes my ordered pair solution. So my ordered pair solution for this system is 4, 4. Alright, so now moving on to the elimination method. Now with the elimination method, we want both equations to be in standard form, such that the x terms, the y terms, and the constant terms are all lined up vertically. So you see here with example number 7, we do have that. All the x's are lined up, all the y's, and all the constants. They're all lined up on their respective sides of the equal sign. All right, so that's what we want as far as a setup for our elimination method. The way we want the elimination to work is that we want to be able to add the equations vertically such that one of the variables is going to drop out to 0. So if you take a look at this first example, number 7, when I add the two equations vertically, combining like terms, you're going to notice that the x's go away. Right? Negative 2x plus 2x is equal to 0. That's what we want to happen in the elimination method. Okay? So when that happens, that's a good thing. So now we got to remember, we want to continue on with that process, and we want to add the like terms vertically. So 3y plus a negative 1y is a positive 2y equals negative 23 plus 5. Add those together, we get negative 18. So now we're left with an equation with just one variable, which we can solve for pretty easily. All right, so we get y is equal to negative 9. All right, so now we know we have a solution for this system. We want to find the other half of the solution. So maybe we're going to go ahead and take the second equation and solve for x. So we plug negative 9 in for y in that second equation. Solving for x, we get x is equal to negative 2. So there's our x value. So pair it up with our y value. Our solution for this system is negative 2, negative 9. Now we skip over to number 9. Again, we have our system set up where all the like terms are lined up vertically. However, you notice that if we were to add straight down, negative 5x plus negative 5x gives us negative 10x. So the x's are not going away. Positive 10y plus a negative 6y gives us positive 4y. The y's did not go away. Okay, so what we wanted to happen with the elimination method did not happen. So there's a situation where we might need to, or we're going to need to manipulate or change one of these equations slightly so that one of those variables is going to drop out to 0. So inspecting closely, we're going to see that it would be easiest for us to get rid of the x's, and by changing one of those negative 5x's to a positive 5x. That can be done by multiplying that entire second equation by negative 1. All right, so that second equation now looks like this. 5x plus 6y equals a positive 12. We're going to keep that first equation exactly the same. I'm going to write that below here. So there's that first equation exactly the same. So now I'm going to go ahead and add those two equations vertically. And we see now that one of the variables, in this case the x's, drops out to 0. Again, that's what we need to happen for the elimination method. Now the rest of the equation is going to go like this. 6y plus 10y is 16y. 12 plus 20 is 32. Right? Here we're left with an equation that we can solve for y very easily. Alright, so now that we solve for y, we need to solve for x. So using that first equation, I'm going to plug in 2 in for y, solve for x, and I get x is equal to 0. So my ordered pair solution for this system is 0, 2. I'm going to finish up here with example number 13. All right. Again, we want to use the elimination method, and we want one of these variables to drop out to 0. So here's a situation where we're going to need to change both equations in such a way where one of the variables is going to go away. All right, so I'm going to go ahead and decide that I'm going to get rid of the x's. And here's how I'm going to change those equations.